Okay, welcome to Probability and Statistics. Today we're going to do a problem that has to do with intersections and unions primarily. So we have this chart, which could be for in this problem it's discs, but they either have a high or low shock resistance or a high or low scratch resistance. And scratch resistance, having a high shock resistance is equal to A. So I'm just going to change this A for shock resistance. Just put an A right there so I know what that is. And then B is having a high scratch resistance. So I'm going to put B down here. So this whole row is B and this whole row is A. This is having a high shock resistance or having a high scratch resistance. So now we have to find probabilities for certain combinations from this chart. So if we're looking for the probability of A, so the probability of having a high shock resistance, well, we know that this all these values add up to 100. So that's going to be our total value out of however many will give us our probability. So in this case, having a high shock resistance is equal to 70 plus 16 out of 100. Because high shock resistance is this entire column right here. They all have high shock resistance. And you can ignore scratch resistance for this point. But they all have high shock resistance, and there's 100 total. So you add them up, and then divide them, and this will give you 86. So that's your probability of A. Now, a probability of B is equal to having a high shock resistance, or scratch resistance, I'm sorry, is this entire row right here. So 70 plus 9 all over 100. Which is going to equal 79.79. I'll circle these. Alright, and now one more quick easy one. Probability of not A. In statistics, this little apostrophe counts as a not. So if you know computer engineering, not is anything that is not what the original variable is. So anything that it does not have a high shock resistance. So looking up at that, well, this all has high shock resistance, so not would be these over here, which have a low shock resistance. If there was a medium in here somewhere, then it would also be included in not. So anything outside of this row or column right here is a not. So looking at that, that's going to be 14. 9 plus 5 over 100. Which is equal to 14 over 100, which is equal to 0.14. So now for the actual unions and intersections. So the probability of A intersected with B. So this is basically, again, using a computer engineering relationship, this would be an AND statement. So what is the probability of A and B? So having a high shock resistance and having a high scratch resistance. Well, if you're looking up at your chart, A would be this right here, and then B would be this right here, but the AND is only where they intersect, so right here, hence the intersection rule. So if you have learned about Venn diagrams, you can kind of see how this would work, but so 70 is going to be the intersection of A and B, so 70 out of 100. 0.7, there we go. So now we're going to do a union, so the probability of a union with B, and in this case it's an OR, so basically all of A, the probability of all of A and all of B occurring. So looking up here at this, you have all of A and all of B. Now, the thing about this is, while the probabilities are included, 70 is included in both of them, and you are taking all of the probabilities, you don't multiply 70 by 2. Some people get confused by this. Just because you have A or B doesn't mean you multiply 70 by 2 because it's included in A and it's included in B. No, you just take the values that are contained. So this is going to be 70 plus 9 plus 16 all over 100, and this will give you 0.95 of having either a high shock resistance or a high scratch resistance. So, and now for the last one, probability of A not union with B, or A naught or B, is equal to, well, looking up here, A naught is this column, and B is this row. So for B, you just add these all up, these three values up that are contained. So you got 70 plus 9 plus 5 all over 100 equal 0.84. And that's unions and intersections. It's actually pretty easy. These charts can get a little bigger, a little bit hairier, but it's not any more complicated than this.